Hello everyone, welcome to Genius Blossom. In this part, we will discuss the topic Can matter change its state? We all know from what we see around us that water can exist in all the three forms of matter. The three forms of matter we know that solid, liquid, and gas. Ice is the solid form, and water is the liquid form, and water vapor is the gaseous form. But what really happens inside the matter during these changes, or what do the particles do? And how exactly does this change happen? We need answers to these questions, and let us try answer these questions together. First of all, we will look at the effect of temperature on matter with a simple activity. Let us take about 150 gram of ice in a beaker and place a thermometer so that its bulb touches the ice. We will start heating the beaker slowly on a low flame. Note the temperature when the ice just begins to melt and then again when all the ice turns into water. Now with a glass rod, keep stirring the water and continue heating it. Watch carefully as the water starts to boil and record the temperature until most of it has turned into vapor. What is really happening here? As we increase the temperature, the particles inside the solid, here solid is the ice. The particles inside the ice or solid, they gain more kinetic energy. And kinetic energy, it is the energy for motion. And as a result, they start vibrating faster and faster, or they start vibrating with a great speed. And this energy supplied by the heat, it overcomes the strong force of attraction between the particles and they leave their fixed position. That means as a result of this higher kinetic energy, the particles or this higher kinetic energy helps the particles to break the strong forces holding the particles together, and the solid melts into a liquid. The temperature at which this happens is called the melting point. That is, melting point is the minimum temperature at which a solid melts into a liquid at the atmospheric pressure, or the minimum temperature at which a solid turns into a liquid at the atmospheric pressure is called the melting point. And the melting point, it tells us how strong the force of attraction is between the particles in a solid. That is, the melting point of a solid is an indication of the strength of the force of attraction between its particles. The melting point of ice is 273.15 Kelvin or 0 degree Celsius, and the process of melting is called fusion. The process of melting involves change from solid state into liquid state, and that process is called fusion. And the melting point, it is the minimum temperature at which a solid melts into a liquid at the atmospheric pressure. It is the melting point, and the process of melting, it is called fusion. When a solid melts, its temperature remains the same. So where does the heat energy go? Or when ice melts, its temperature stays the same until all the ice turns into water, even though we keep heating it. So where does the heat go? And that heat, it is used to break the strong force of attraction or the strong bonds between the particles of ice or solid and helping them become water or liquid. And since this heat, it doesn't raise the temperature, it is called the latent heat, and that heat is called a latent heat. And the word latent, it means hidden. The word latent means hidden. So it is also known as the hidden heat, because that heat, it doesn't help to raise the temperature. So it is called the hidden heat or latent heat. And the amount of heat needed to change 1 gram of solid into liquid at its melting point, it is called the latent heat of fusion. Latent heat of fusion. Fusion, we know that it is the process of melting, and the amount of heat needed for the process of melting, it is called the latent heat of fusion. And that is why water at 0 degree Celsius has more energy than ice at the same temperature, because it has absorbed this extra hidden heat. When we heat water, what happens? Its particles, they move faster and faster, and at a certain point they gain enough energy to break away from each other and turn into gas. And this specific temperature, it is called the boiling point. So boiling point, it is a temperature at which a liquid starts boiling at the atmospheric pressure. And this boiling, it happens throughout the liquid, or it happens or it takes place throughout the liquids. That is why we can say that boiling is a bulk phenomenon. But what about melting? Melting, it happens only on the surface. So we can say that melting, it is a surface phenomenon. Then the boiling point of water is 100 degrees Celsius or 373 Kelvin. We know that the melting point of ice is 0 degrees Celsius or 273.15 Kelvin. And but for our school level calculations, we simply round it off to 273. Water boils at 100 degrees Celsius, and to convert this into Kelvin, we just add 273, that is 100 plus 273 is equal to 373. So the boiling point of water is 100 degrees Celsius or 373 Kelvin. And the amount of heat required to change 1 gram of liquid into vapor or gas at its boiling point without any change in the temperature, that we can say that it is the latent heat of vaporization. So the latent heat of vaporization, it is the amount of heat required to change 1 gram of liquid into vapor at its boiling point. And just like melting, this heat, it doesn't rise the temperature, but it helps in changing the state of matter. For example, steam at 100 degrees Celsius, it has more energy than water at the same temperature because it has absorbed this extra hidden heat. So, what is the latent heat of vaporization? That is the amount of heat required or amount of heat needed to change 1 gram of liquid into vapor at its boiling point. That is, when we change the temperature or when we increase the temperature, the particles, they move faster and the substance can change from solid to liquid or liquid to gas. And when we cool it, the reverse process happens. That is, it goes from gas to liquid or liquid to solid. So we infer that the state of matter can be changed into another state by changing the temperature. But some substances like camphor or ammonium chloride, they didn't go through the liquid state when heated. Instead, they changed directly from the solid state into the gaseous state, or they changed directly from solid to gas, and this process is called sublimation. So what is sublimation? That is a change of state directly from solid to gas without changing into liquid. It is called a sublimation. And if the gas, it changes directly back into the solid without becoming liquid, it is called deposition. So what is sublimation? Sublimation, it is the change of solid state into gaseous state without changing into liquid state. And then what is deposition? Deposition is the change of gaseous state directly into solid state without becoming liquid state. To observe how sublimation happens, crush some camphor and place it in a china dish. Cover it with an inverted funnel and plug the funnel stem with cotton. When you gently heat the china dish using a burner, the camphor starts to disappear and you will see some white solid particles collecting on the inner surface of the funnel. This shows camphor turning directly into gas and then back into solid, a clear demonstration of sublimation. We studied the effect of change of temperature on matter, and now we are going to study the effect of change of pressure on matter. We already know that the main difference between solids, liquids and gases is how far apart their particles are. So if we take a gas in a container and press it by applying pressure, what happens? The particles start coming closer and closer. That is, increasing pressure can force the gas to become a liquid. That means by increasing or decreasing pressure, we can change the state of matter. Yes, we can change the state of matter by changing the pressure. For example, when we compress a gas by applying pressure and cool it at the same time, it can turn into a liquid. That is exactly how liquefied petroleum gas or LPG is made. The gas is compressed and stored in cylinder under high pressure. When released, it comes out as a gas again. Have you heard of dry ice? It is the solid carbon dioxide and it is stored under high pressure. When the pressure is reduced to normal, what happens? It changes directly into a gas without becoming liquid. That is why we call it as dry ice. So we can say that both temperature and pressure decide whether a substance will be solid, liquid or gas. Let us have a look at the interconversion of the three states of matter. A solid, it can change into liquid by fusion or by the process of melting. Similarly, liquid can change into gas by vaporization, and a gas can turn into liquid by condensation, and liquid can change into solid by solidification. And a solid, it can directly change into gas through sublimation, and like that a gas can directly change into solid by the process of deposition. Convert the following temperature to Celsius scale. A 300 Kelvin, B 573 Kelvin. And now we will learn how to convert a temperature from Kelvin scale to the Celsius scale. Just remember the formula. Celsius is equal to Kelvin minus 273, or Kelvin minus 273 is equal to Celsius. So in this question they have given 300 Kelvin. Now using the formula we subtract 273 from 300, that is 300 minus 273, it is equal to 27 degrees Celsius. So 300 Kelvin is equal to 27 degrees Celsius. Now let us try the second one, that is 573 Kelvin. We use the same formula, Kelvin minus 273 is equal to Celsius. So 573 minus 273 equals 300. That is 573 Kelvin is equal to 300 degrees Celsius. What is the physical state of water at A 250 degrees Celsius, B 100 degrees Celsius? At 250 degrees Celsius, water exists in the gaseous state. This high temperature turns water into steam as it has long crossed its boiling point. At 100 degrees Celsius, water exists as both liquid and gas. This is the boiling point of water where it transitions from liquid to steam. Why does the temperature remain constant during the change of state? During a change of state, the energy supplied is the latent heat, which is used to break the force of attraction between the particles. This energy does not raise the temperature. Suggest a method to liquefy atmospheric gases. Atmospheric gases can be liquefied by applying high pressure and lowering temperature, and this reduces the kinetic energy of gas particles, allowing them to come closer and change into the liquid state.